In this video, we'll consider another example on conversion of complex numbers. This time around, we are converting the arctan of a complex number, or we are expressing the arctan of a complex number in its Cartesian form, which means when you take the arctan of a complex number, what exactly is the result going to be in Cartesian form? This is what we want to get and see what the value will be. So how do we proceed? First and foremost, let us try as much as possible to simplify this expression as much as we can. So in this case, again, we start from the inside. Let W be equal to 1 plus I. If this is the case, then it means that Z would be written as arctan of W. Now we're getting somewhere. Now, if Z can be written as arctan of W, then by the concept of differentiability, we would have that dz divided by dw would, of course, give us 1 divided by 1 plus w squared. This is a standard differential for the arctan function. Now, do not forget that w is in fact 1 plus I. So this means we're going to have this to be 1 divided by 1 plus 1 plus I all squared. Now, we can go further to expand this as necessary. And if we do, we would have this to be 1 divided by 1 plus 1 plus 2I plus I squared. Now, we bring it all together. You have I squared, which is minus 1, cancels out one of the ones. You'd have that the Z, the W, would in fact be 1 divided by 1 plus 2I. That is what we would have. Now, we can rationalize this function by multiplying by 1 minus 2I. And the result of this would be 1 minus 2I on top, divided, of course, by 1 squared minus 4I all squared. Right? Now, remember, this is how rationalization will work. A plus B multiplied by A minus B will give you A minus B squared. So this works in case. So of course, this will be 2I, this will be 2I all squared. So simplifying this, you would have that the dw will now be 1 minus 2I divided by 1, right? I squared is minus 1, 2 squared is 4, so this will give you 1 plus 4. So you're going to have this to be 1 minus 2I divided by 5, right? So again, dw breaks down into 1 divided by 5 minus 2 over 5I. Now, this is very, very interesting because we can write this as the Z equals 1 over 5 minus 2 over 5I dw. And from here, we can evaluate the integral on both sides. So that if we evaluate the integral, we will then have that Z will be equal to 1 over 5 W minus 2 over 5I W. This is how we evaluate this. Of course, there is a constant of integration that comes out, which is plus C, right? That's a constant of integration. Of course, you can assume that the constant is 0. You can assume that the constant is another number. That is totally fine. Now, from here, don't forget that since W, of course, remains 1 plus I, then it means we could rewrite this function as Z equals 1 divided by 5 multiplied by 1 plus I minus 2 divided by 5i multiplied by 1 plus I and then plus c, right? So z would be equal to, splitting this up, 1 over 5 plus 1 over 5i minus 2 over 5i. I times I is I squared, that gives you minus 1. So you have plus 2 over 5 and then plus c. So 1 over 5, 2 over 5, that gives you 3 over 5. And then 1 over 5 minus 2 over 5, that gives you minus 1 over 5 I plus c. Therefore, we see that z is indeed 1 over 5, 3 minus I plus c. And this is our final answer for z. So if you set c to be equal to 0, then this would be your only answer. If you set c to be any other kind of value, then it will still serve as the complex number. So there you go. What we have done so far is to play around with the value of the arctan, right? Making the substitution within it, differentiating the function, then reversing the process of the differential by taking the integral of both sides, such that we are now able to return back to the original form of the question. Of course, we can do this because we know that first and foremost, the basic complex number is, of course, differentiable, and the value of the arctan is also a differentiable function, right? So long as there are no fractions to deal with here, and so long as the value of w, which is 1 plus I here, does not magically become infinity, then definitely we know that tan inverse of w will exist when we find the differential of that function. And that is satisfied as far as this question is concerned. So make sure to go through the solution, go through the process. You could watch and rewatch and make clarity as much as you can. If you also have some questions you'd want us to help solve, make sure to also drop them in the comments as necessary. As always, like, share, and subscribe, and we'll see you in our next video.